Abhilash is going to be talking about scaling up vOLTHA.
Yeah.
Over to you.
Thank you. I'm Abhilash. I work as an architect in Radisys, and also I work with vOLTHA along with Linux Foundation. I usually don't do this. So my colleagues, Robert, Hansjörg, and Fran do this usually. So they have helped me out this time. Thanks, everyone. Thank you all. Thanks, Robert, for the PPT. Hope you all like it. If you don't, you know whose idea was it. So going on, I would really like to thank BBF as well to open the floor for everyone to share their experiences and also innovations. And lastly, I would like to thank DT to keep the vOLTHA and the LF broadband running, helping scale and also bringing in new features and stabilizing vOLTHA. Thank you. So I'll start with vOLTHA. So just to brief what vOLTHA is, this is a disaggregated solution. What we have everything running in the vOLT out in the cloud or in the x86 machines. So we have vOLTHA core, which basically is a master of all the adapters. We have the OpenVNU adapter, we have the OpenVOLT adapter. And also we have controllers like ONOS. We also have in VGC, which we have introduced new, which is our new scaling, which scales well than ONOS. And also we can have in vendor adapters as well, along with the OpenVOLT adapters. And we do have in DT already. So the example here is a white box OLT. So we can probably skip that part because mostly we are concentrating on the vOLTHA part here, which is the core, the VNU adapter, the vOLT adapter, and the controller. Yeah, so this, it works good on paper. Everything seems nice, but once you start scaling, right, that is where the problems come in. And we have worked along with DT, along with Turk Telecom, along with Linux Foundation to help scale vOLTHA. So how do we scale it? So we have BBSIM, which is basically a broadband simulator, which simulates the OLTs and ONTs. So once they are up, they literally simulate all the messages, the OMCI messages, and what all OLT wants to communicate. So by this way, we can simulate OLT so that we can scale and test the vOLTHA control plane. And also we have the VGC, the vOLTHA Go controller, which was a Radisys product, but open source to the LF Linux Foundation to scale better along with vOLTHA, because we found owners to be a bit resource hungry all the time. And I'll go on and showcase some of the numbers what we have. So yeah. So what you see here is a stack. A stack is nothing but a controller and the vOLTHA core along with the adapters. It can be any adapter. It can be a vendor adapter or an OpenVOLT adapter. So you see here in the first one, we have two stacks. This is on the 2.12 version, which is the one which was released earlier. So we have 8K ONUs. The number of OLTs are 8 and the PON ports are 16. So you can mix and match with the BBSIM, which can give you how many number of ONTs you want, how many number of PON ports you want. And if you look at that, we have cores being used by vStack is 8.7 and cores used by etcd is 7.8. That would be fine, but I'm most interested in the memory. If you see the stacks, it's almost like 11 gigs. And that's only with 8K subs. Now, if I move to the last section, the 24K, so we are jumping the total vStacks consumption is already 29 gig. So that's a lot if we are scaling. And also the tests done here are not really practical. They're like all the OLTs come at one shot, all the ONUs come at one shot, all the subscriber configurations are happening in parallel, all 24K, which really is stretching the vOLTHA and all the infrastructure services. So that's a test we really wanted to do, and we really wanted to test, stretch the stacks and the infrastructure services, and that is what we got. So the concern was the memories now going on, and what we have improved on. This was 2.12, and this is 2.13. So if you see, the main resource consumption was from the ONU adapter. So we have literally gone down from 7 gigs to 1.8 gigs per stack, I mean per instance. So it's somewhere around 70% of reduction. And we did a bit of in core as well. We did a bit of in vOLTHA adapter as well. So the VGC, we didn't have to do it, was pretty efficient by itself. And going on, this is just to give a brief. We have 22 gigs against 5 gigs. And this is what we were able to pull off. And this is with scale, with so many ONUs coming up and stretching the control plane literally to its max, which usually doesn't happen in the real production scenario. So overall, we have somewhere around more or less 50% reduction with the whole stack. And what next? So scale, yes, there is always work to do in scale. Things should improve. We are working on it. And also we are working on some of the DB operations to reduce, because if you see, there is a lot of spikes in the DB operations because there are a lot of writes being done. So that we are planning to reduce that, and also reduce the CPU consumption. Hopefully it should work, and stabilize some of the corner case scenarios, like corner case wherein you have things going off, things turning off, things rebooting, things restarting, pod servers restarting. So those cases we are working on to stabilize it, and hopefully things will go well. And yeah, that's all I had. Any questions?
So from your side, I mean, obviously Turk Telekom and Deutsche Telekom have been very big supporters.
Yeah, definitely. Yeah.
Where are we in the deployment scales these days, not just in those, but in other nations?
Yeah, so we have already pilots running with DT. Probably Fabian can pitch in as well. So we already have successful pilots run with multiple vendors already, and we are going to next level, the next set of production.
Yeah.
So it's going well. And we have the same, if not similar, stack running in our Radisys vOLTHA as well, which is already deployed in Reliance. Yeah, it's running millions of customers there.
Millions.
Yeah. And the one which is running in DT is exactly the same what is there in the LF. No changes, not even a single line. It's exactly the same. So
yeah, our deployments in production are not yet as advanced as Geo has, but we're getting there. It's in all our validation environments. It's we can verify the numbers. Looks good. And also, by the way, great work. This is really important to make vOLTHA and disaggregation in the PON space viable. So we are still following the approach to go with vOLTHA in our big first deployment of A4.
yeah,
Yeah,
will not disappoint you.
Very good.
And from a Broadband Forum point of view, we are enjoying and we're working closely and collaborating with Linux Foundation, the BB side of Linux Foundation, and we'll continue to do so. Yeah.
Thank you.
Any other questions? Then thank you so much.
Thank you very much.